Hello, check, check one, two. Hello, 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 check. Hello, hello, check, check. Hello, hello, check, 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 check. Hello, check.
हेलो हेलो।
हमारा नाम कुमार नाम काट दीजिए क्योंकि
हाँ,
हमारा ऑफिस से थोड़ा सा अर्जेंट काम है, निकलना है।
अच्छा, आप नहीं कर पाएंगे?
हाँ,
हाँ,
नहीं कर पाएंगे, ठीक है अभी।
कल टुमारो।
तुम्हारा तुम्हारा देखते हैं सर, हाँ तुम्हारा बता दें।
हाँ, ओके ओके। हेलो। Good evening, everyone. Very good evening. On behalf of NPL, 1 week One Lab Organizing Committee, we are welcoming you all. As per our ongoing scheduled program, Startup MSME Industry Meet, now we have a plan to conduct technical showcasing, short presentation, panel discussion. We are planning to conduct a technical showcasing from industry and a short presentation from industry, startup and our NPL scientists. Then finally we have panel discussion at the end of the day. On behalf of these things, we have three industrial presentation. First one is Ravi Kumar from Earth Startup from IIT Kanpur. Then next one is Dr. Balveer Singh from industry, and the third one from NCCP. Then one from Dr. Takate, Chief Scientist, Materials and Devices Metrology Division. Attend this lecture and participate in this discussion. Then you can get it benefit from our NPL scientists, industry and MSME. So now first the door is open. Mr. Dr. Ravi Kumar from Earth Industries Startup, IIT Kanpur. Please. Your time is 20 minutes and 5 minutes or 10 minutes panel discussion.
Okay. Hello everyone. This is Ravi Kaushik. I'm a graduate from IIT Bombay in environmental science domain and working on this startup for last with professors from IIT Bombay, IIT Kanpur and Indian Institute of Science Bangalore. A brief background, I have worked extensively in aerosol science domain, particularly using instruments like OPS, EPC, SMPS, etc. Done a lot of experiments, lab studies mostly. Then the innovation that I'm going to discuss has been adopted. It's not just innovation in the lab of IITs, but has been adopted by organizations like RBI, ONGC, Stockholding Corporation of India, a cancer hospital, among many others. And the innovation has also been on news, national news channels like Aaj Tak, NDTV, India Today, DD News, etc. So going forward, unsure about the air that we are breathing. We are unsure that what kind of PM particulate matter we are breathing, the gases we are breathing, and we are unsure about the germs that we have around us. So the problem is 99% of world and contrary to common belief, indoor air is much more polluted, approximately 5 times as per studies, than outside. Out of 24 hours, I am sure 18 hours, approximately 90% of our time we spend indoors. In one day, we want to drink 3 liters of water, we want to take 10,000 steps, but we breathe 22,000 times or more in a day without noticing it. But are we breathing clean air? So air pollution and disease transmission is becoming invisible killer and decreasing 5 to 9 years of our lives as suggested by various studies. So this has been our journey. We started with a prototype which was first tested here at NPL, and then we made alpha version, beta version of our prototype of an standalone unit of air purifier, and then we had a alpha version of market ready product. We then sold it out. So this is a problem that we are trying to solve. The filters that we have currently in the market use, the germs are captured within the filters. The filters allow growth of germs, and these germs can again resuspend back in the air around us to infect. So the validation that we have done, so what you can see on the second side, the coated side is our filter that is coated with plant-based enzymes. Polyphenols destroy germs. Not only it captures it, but also destroy it. That is how we are different from any other kind of filter that is available in the market. The validation that we have done, it is able to remove 100 nanometer, which is approximate the average size of SARS-CoV-2, and 300 nanometers, which is MPM, that is most probable size which is able to go through a filter media. That has been tested at here at CSIR-NPL in 2020 June. Then we have tested for deactivation on the original variant from one of the CSIR IMTech, Institute of Microbial Technology, Chandigarh. Then we have tested not only virus, we are able to destroy bacteria and fungus as well. That has been tested at TUV Rhineland. Then deactivation of black fungus, because of the havoc that black fungus has created, we have tested on mucormycosis or black fungus. Tested that we are able to deactivate drug resistant microbes which are susceptible to drugs. We are able to deactivate them. That has been tested at CDRI Lucknow. And this entire coating that we are doing is not copper, silver or graphene based, which are heavy toxic metals, but plant based enzymes, polyphenols and polycationic polymer. And it has been tested that it is human friendly and environment friendly. These are some of the certifications that we have, as you can see, from IMTech, from National Immunogenicity and Biologicals Evaluation Center, and again at IMTech. So for big buildings, the problem remains that one of our system cannot. Yeah, that was the problem. We understood the problem for big buildings is very high cooling bill that they get, the low life of AHU filters that they have, and the huge pressure drop of media filters that they get. Because of which the inefficient AHU filters, they are getting a lot of higher energy bills, completely inefficient to capture any kind of PM10, PM2.5 or any kind of germs. So then we developed for large buildings CEAC, that is coated electronic air cleaner, which is most efficient AHU filters for big buildings that prevents pathogens in the building, and also your AHU runs at the optimal airflow. And to save on electricity cost, you get higher filter life and you get buildings. So this is how the working principles look like. The dust is charged and we have coated collector plate that can capture normal air purification process, how it looks like. We pre-filter first stage, second stage the medium filter or fine filtration, and then HEPA filtration. So what we do is we are CEAC coated electronic air cleaners, and that delivers clean air at a much lower pressure drop. So in IPD, initial pressure drop, you can see 50 plus 100, approximately 150, we replace it by only 20 pascals. So that lead to a lot of increase in airflow. So dust holding capacity, as you can see, this is one of the sites where we removed the dust that has been captured by our filter. This is a pilot that we have done in one of the malls in Delhi, Vegas Mall, Dwarka. It has inefficient system. We did an AQI audit and energy efficiency audit, figured out that the AQI readings were really high, the air pollution level were extremely bad, and the airflow through their AHU or the air handling unit is really low even than the designed CFM. What we then did, we installed our system. What we were able to see two things. One, the air quality improvement. We were from outside, we compared what's the AQI inside. As you can see, the red bar graphs are what is outside, and with blue is something that we were able to achieve with our system. So even when we are serving food court area for a big building, which is like most polluted area in any mall, we were able to get really good in terms of air quality, more than 80% always. Then second was energy efficiency that we were able to achieve. Around 82% of energy we were able to save here of the AHU blower. How we were able to do that is because after installation of our system, the airflow increased from 14,000 CFM to 28,500 CFM. Now to match it again to around 15,000, we decrease the frequency or we lower down the RPM, and that helped in decreasing the power. So efficiency as well. So this is the value proposition for large buildings that relax. You can breathe clean air. When AQI outside is 400, you will still get 50, and your HVAC or AC system becomes more efficient. You reduce carbon emission. Air quality monitoring can be done with communication with the occupants, and then you reduce your OPEX, operation cost. You get better ESG and EHS compliant, and you get greener building. So this is the value proposition that we give for big building clients. But the problem remains the same for homes, right? We have never discussed about homes. We have discussed about large buildings, but what should we do for homes? And this is what we have come up with after a lot of iterations. Can we make air purifier for ACs? Because right now ACs, what they are doing is they are recirculating your polluted air over and over again. That's how you convert your AC into an air purifier. That helps you from protection against PM 2.5, PM 10 germs, and makes your AC more efficient because now the maintenance has been reduced. So this is how it actually works. And the process is very simple. It pulls polluted air using air of the filters for, and this is how it looks like in a real life situation. But there are other AC filters available in the market. Those other AC filters, 15 of those other AC filters make one of our filter, and we are available at a very pocket friendly price, because this is what we have understood from various interaction that we've got from breaking the cost barrier for clean air, reducing the cost of an air purifier from 20,000 to approximately 2,000 rupees. So this is how you convert your AC into an air purifier without any electrical connection required, no battery required, and easy DIY installation. This entire development has been support from Department of Science and Technology. This is official press release by Ministry of Technology on our innovation from their website. And we have been on even on the front page, on the home page of IR. And we have been on various newspapers, including the Hindu, Business Insider, India Today, Your Story, Business Standards, Z News, among many other news inserts, how we are converting ACs into air purifiers. And this is available on Amazon, and in last 3 months we were able to sell more than 500 units. That give us an impact that yes, people do believe in startups and the innovation that we do. And awards on recognition, I'll skip this. Industries, in RT-PCR lab, they were getting a lot of false positive and false negative. With our system, the false positive and false negative able to achieve near sterile condition. Stockholding Corporation of India, patients who were undergoing bone marrow transplant. So we have been to that level. And in a food and beverage industry, because on a cut fruit you get a lot of microorganisms on the fruits. So we were able to, in a factory where they were packaging it, they were processing the cut fruits, we were able to reduce the microbial growth, and they were able to export the cut fruit to other countries. So really proud of that. This is our two from IIT Bombay again, Pushan from NIMS Mumbai MBA graduate. skipping on this, but we are fighting air pollution and climate change. Thank you for your time. Good day. Our stall is there. If anybody has any questions, happy to answer right now or after this presentation. Any questions? I think no. Sir, yeah, done. Thank you very much.
Hello. Hello. Now, any hard discussion from audience side? Any queries?
Hi. Filter material kind of mesh with surface area, or it is something? The material with lower surface area, probably you can try out with carbon fibers and so on. You may discuss with the group existing in NPL.
So
Or
what? Right.
group
So what?
works.
We are using HEPA filters grade 10, but they are coated. The filters are coated with our plant-based enzymes which can destroy germs. And how it we have two variants. One is summer, one is winters. You can actually see for ACs the kind of filters that we have, glass fiber mostly, but grade 10 HEPA filters coated. Carbon filters can
It
be
has
used,
nothing
but
to do with the surface area, you mean?
surface area, correct. HEPA filters have like the largest surface area, right? No comparison with any other kind of filter. So that has been taken, that has been considered.
Okay.
Yeah, thank you.
Any queries from industry? Stalls? Okay.
Thank you.
My question.
Yes.
How much cost effective your filters?
Very cost effective, sir. See, you buy an air purifier for 10 to 20,000 rupees. We usually use it for 1 month or 2 months, right? You buy this system for just 2000 rupees, and whenever you turn your AC on, it will work, right? This is the feedback that we've got from many customers, that they will purchase air purifiers for their parents, old parents, or their young children, but never this is a habit that they are going to turn their air purifier on. But with our system, they are going to turn their AC on, right? And once they turn their AC on, they are going to get clean air. So this is an added advantage. At just 2000 rupees, at least for 8 to 10 months, you can get clean air.
Okay, then your component, what you are comment to, I like to call Dr. S.K. Dakate, Chief Scientist. Distribute this comment. Big applause, please. Now we are moving to second presentation from Dr. S.R. Dakate, Chief Scientist, Advanced Materials and Device Metrology Division.
ये खोल दो वैसे डायरेक्ट हाँ डायरेक्ट चला क्या हुआ कोई नहीं हुआ कोई किसका ये पहले बंद करो ओके चलेगा ना हाँ हाँ कहाँ स्विच करो Okay. Okay, thank you very much, Dr. Sravanan.
Uh, so organizer asked me to give some presentation on the carbon related material. Actually, we are working on carbon based material particularly. Our group is more than 50-year old, and it is working continuously from different type of carbon materials. So today I am just giving some overview about what we are doing in NPL and what is their importance in the perspective of industrial application, and how can MSME or other industry can take this forward into the production. So first, when you are talking about the carbon, first impression about this carbon material, we can say it is a dirty. It can make our hands black, but not. It is a, even though it is a black, but it is very important material, and it is a very technological important material. And if you know, this material got 2 Nobel Prize, first for furulence and another for graphene. The graphene just discovered in 2004 and got Nobel Prize in 2010. So that is the that is why these carbon-based materials are important. So you know, coke, coal. So from long time we know the coal is used as a fuel in our homes and everywhere. Then there is a charcoal, soot. There are different form of carbons, and it is almost graphite and other things. So coal is used. Miss, आवाज? अरे यार आवाज एक मिनट. Okay. So you already know coal we are using for energy generation as a fuel. On the other hand, it is used for metal reduction. If you know the steel industry in the country, they are using coal as a raw material, and they are converting coal. Metallurgical coke is used for the reduction of iron ores to get the irons. So these are the different examples. From 1779, 1789, this graphite and diamonds are discovered. And there are different form of, again, carbons which are exist. That depend upon which type of hybridization, sp2, sp3, or sp1. So just I want to show this having the group of 14, periodic table 2 and block P, atomic number 6. If you know the melting point, why this material is so important, because it's made more than 3500 degrees centigrade, as well as the boiling temperature of this material is very high, more than 3800 degrees centigrade. If you know the density, there are 2 main allotropes we know, everybody know, graphite and diamond. Graphite have in the range of 2.26 gram per cc, whereas diamond having the density 3.5 gram per cc. So it क्या हुआ? आवाज नहीं क्या? रेड है? हाँ? हो गया? रेडी होगा? आवाज आ रही नहीं? Okay. So there are 3 different isotopes also of element in the earth. And if you know anybody, anywhere, if you can consider only human body, that having second most abundant element in the human body. So whatever human body, our tissue, whatever bones, whatever blood, if you see that there is a carbon always present. So that's why this is very important material. So one interesting thing is that there are processing parameter. We can get variety of carbon. If you want porous carbon, if you take any type of carbon, activate it by some chemical treatment, physical treatment, you can achieve the very high surface area. There is another form of carbon, that is glassy carbon. that having the zero porosity, means impervious to the gases. On the other hand, electrical insulator is diamond and amorphous carbon, very high electrical conductive carbon nanotube, pitch-based fiber, thermal insulator, carbon felt, high thermal conductivity composite, this carbon-carbon composite, which conductivity better than copper. You know all, graphite is a very lubricant material with soft material, so it is used number of lubricating application. On the other hand, diamond and glassy carbon is abrasive. So these are the very, very different combination of property can be achieved in the one that particular material is a carbon material, and that's called, this material is a carbon black art. So I just told you means coal and coke. So from coal, when they want to use in the metallurgic steel industry, they have to convert into coke, into metallurgical coke. So when you are converting this coal into metallurgical coke, there is a byproduct, that is one byproduct in the form of slurry, we can say coal tar. So that coal tar having a lot of value-added product can be developed because they are that having almost 50% carbon element. So from there, you can again do the fractional distillation, and we can make coal tar pitch. And when doing the fractional distillation at different temperature, we are getting different types of liquids. So that liquids having also the value, they are also used for different type of industries. Okay, and after that, we can use these materials for different variety of applications. So from converting coal tar to coal tar pitch, so what happened when you are converting coal tar into coal tar pitch? Lightweight molecules we are removing, and aromatic structure is remain in the coal tar pitch. And from that coal tar pitch again, we can make different value-added product by different processing. So one of the product is a coal binder pitch. So you know the graphite electrode. So in graphite electrode, they are using the coke as a reinforcement and binder pitch as a binder. So that is the one application of binder pitch in the formation of graphite electrode, that is synthetic graphite electrode. Carbon fiber as a reinforcement and coal tar pitch as a binder. So again, this coal tar pitch having the 50% carbon content. When we are carbonizing carbon fiber reinforced, then we have to fill that porosity by impregnating pitch. Okay, so that's why it is called impregnating pitch. So impregnating pitch and coal tar pitch having different properties in the respect to softening point, their quinoline insoluble content, toluene insoluble content, and density. So another material we can get from coal tar pitch is mesophase pitch, or and from mesophase pitch also, during formation of the mesophase pitch, there is one intermediate stage, that is MCMB, mesocarbon microbeads. So from that mesocarbon microbead, we can, just like a spear, we can develop. That spear very useful as a raw material as a anode material for lithium-ion battery. Again, when we are heat treating this coal tar pitch to high temperature, 900 to 1000 degrees centigrade, we can generate needle coke. So nowadays, needle coke is used as a raw material for synthesis of very ultra high pure carbon electrodes. So these are the just I am chemical oils and creosote oils. So coal tar pitch generally used in aluminum and steel industry. From chemicals oils, we can make naphthalene, phthalic anhydride, and they are having different applications. So when we are converting coal tar pitch into different value-added product further as a carbon anode material, cathode, other specialty carbon materials, then this can be used, these chemical oils can be used for different application in the area of construction. Creosote oil, that is around 30% when you are distilling the coal tar. So that having, so if you see when coal tar is distilled at different temperature, we can get different types of materials. There. So one of the application when we are making this coal tar, anode, cathode material of lead acid batteries, because you know the lead acid battery when we are using lead is a electrode, so it having very high density. If we can use carbon foam as a electrode, so it is a lightweight also. Then is a high density graphite is one of the material can be made from coal tar pitch. So that having different type of applications. Okay, so solid lubricant, ball bearing, carbon artifact. Even we can make the die mold to heat treat the material at high temperature up to the 3000 degrees centigrade. So for that applications, this high density graphite is used. Yes, I told the mesocarbon microbeads. So generally, you know, in a lithium-ion battery, graphite is used as an anode material. But there are limitations of the graphite to get its capacity, achieve the high capacity. On the other hand, when using the MCMB as an anode material, again by same process on coating these mesocarbon microbeads on copper foil, and it acts as an anode material, the capacity is almost double. So this is the one application of this material. So another is the, so if you know, there are different type of fibers in the market, but carbon fiber is different. So carbon fiber is again the fiber having diameter in the range of 5 to 10 micron, and it's completely composed of carbon elements, around more than 95%. Okay, why? Yeah, glass fiber. So if you see the density of this carbon fiber is 1/4 of the steel, whereas 10 times stronger than steel and aluminum. It is a corrosion resistance, it cannot rust, and there are chemical resistance and so many properties. So that's why this material is very important, and there are going to be used in almost many applications. If you know, and the carbon fiber, so it is 1/4 of the density of the titanium materials. That's why nowadays most of the aerospace industry, they are using the carbon fiber jets. So it is just I am showing you here how the processing of the carbon fiber. So again in this processing there is a precursor, that is a polyacrylonitrile that is a petroleum based material. So that is a PAN, polyacrylonitrile. So that can be spin into the fibers, but it's very difficult to spin the polyacrylonitrile as such. So industry is converting. So almost all the carbon fiber made from in the market, they are PAN-based carbon fiber. So they are made from the polyacrylonitrile copolymer. So first step, in this case, is just heat treat these polymer fibers at different temperature. So first stabilization. What is stabilization? We have to convert these polymer fibers into stabilized fiber so that they cannot deform. So their morphological heat treatment, heat treating at different temperature. So these are the different stages I have shown in this figure. Stabilization process, then is a carbonization process, then graphitization process. So it is a very small diameter, means in the range of 5 to 7 micron. So handleability is very issue. To make handleability easy, industry is giving the surface treatment of some other polymers, that particularly the epoxy, so that its handleability will increase. So NPL has worked almost 10 years before on the process development of the carbon fiber, and we have the plant to convert the polyacrylonitrile fiber into the carbon fiber. This shown in this figure. This is the plant we have in NPL earlier, and this technology has not moved further, but we have transferred this technology. So these are the different application of the carbon fiber, because these carbon fibers stand up to the 3000 degrees centigrade temperature. So these fibers, composites are used in nose tips of the missile, heat shield, rocket nozzle, thermal protection system of spacecraft, and so many aircraft brakes, engine parts, in nuclear reactor as a fuel tubes, in automobile brakes, clutches, heating elements, and high temperature tooling, dies, in sports. Nowadays in sport, there are a lot of carbon fiber composite are using. And then biomedical, hip joint and various implant. So what is composite? So when we have the carbon fiber, we have to convert into the, because we cannot use directly carbon fiber to any particular application, so we have to make the composites. So again, composites is material made from two or more constituent, but they retain their identity, physical and chemical properties. So in this case, we have the carbon fiber as a reinforcement in the form of different, it may be chopped fiber, it may be continuous fiber, it may be viscose, it may be anything. And then we have the matrix, there is a matrix, is thermostatic matrix and thermoplastic. Then we have the processing, generally we can use a compression molding in the laboratory, so make the carbon fiber polymer composites. So why carbon conventional material and the carbon fiber composites? And we consider specific strength and density. So if you see the carbon fiber polymer composite having density 1600 kg per meter cube, whereas the other materials is more than that. So one issue is it is a lightweight. Another, if you see the specific strength, so in all the materials, titanium, magnesium, aluminum, steel, even glass fiber composite, the specific strength of this carbon fiber composite is very high, almost more than 2-3 times. That's why this material nowadays using in different carbon fiber composite made from carbon fabrics and the polymer resin by compression molding technique. Another is a carbon fiber polymer composite tube. Then carbon fiber polymer CNT hybrid composite, you can add carbon nanotubes also in the composites. So achieve the higher mechanical properties. So any type of material by different processing technique, we can make the variety of shapes from the carbon fiber composites. And nowadays, just I told you, a major application of the carbon fiber composite in the area of aerospace, particularly transport applications. Another is the windmill. The windmill generally made earlier from the glass fiber composite, but nowadays this trend is changed and they are making the carbon fiber composites windmill because the length is very high. So stiffness is one of the important property that carbon fiber is giving. So carbon fiber windmills, almost their length is 60 meter, very huge structure made from the carbon fiber composites. Then I told you the body of the aerospace, Airbus aeroplane, that made from the carbon fiber composite. That is almost 60% carbon fiber composite nowadays using in the aerospace industry. Then another is railways, the railway coaches, how we can reduce the weight of the coach. Ultimate objective nowadays, how to make the energy efficient material. So energy efficient material, one thing that we have to reduce the weight of the components, whatever components we are using, the any type of transport application. Then now that there is a trend, the people are trying to replace cement and steel by carbon fiber composites. So just I am showing, this is the Airbus 7837. This consists of more than 50% carbon fiber composite, and that is a main body structure that is in blue color, that is made from the carbon fiber composite. Earlier it is made from the steel, aluminum and titanium, but to reduce the weight and make the energy efficient. Ultimately, all over the world, climate change is the one issue now. So everybody is trying to reduce the weight and reduce the carbon dioxide emission. So if you can reduce the weight of any transport material vehicles, automatically we can reduce the consumption of the fuel and ultimately the CO2. So these are the one component I am just showing is made how they are making the carbon fiber composite materials for the aerospace applications. This is another area because there is almost 25% contribution of the carbon dioxide emission in the overall carbon dioxide emission in the world. And this sector is automobile. We have a lot of automobiles. I think India having more than 25 crores total automobile. This may be small car, two-wheeler, four-wheeler, six-wheeler, whatever it may be. Suppose if we can reduce the weight of automobile by 100 kg, we can reduce 20 gram of carbon dioxide emission per kg, per kilometer. So India is a huge country. How many kilometers our vehicle are traveling in one day, we don't know. If 20 gram per 1 kg, 1 kilometer, so you think about how much carbon dioxide we can reduce. So that's why nowadays all over the world, the carbon fiber composite are used in automobile applications. So at the present, most of the companies, means if you know the Tesla is using most of the carbon fiber composite in their automobiles. Okay. Another in the racing car, they are also using. But nowadays, one challenge is here, the cost of the carbon fiber. Cost of the carbon fiber when we can reduce. Nowadays, the carbon fiber cost is 5,000 to 6,000 rupees per kg. On the other hand, steel, you can get steel from 100 rupees kg to 300 rupees kg. So cost variation, cost difference is very high. But when we can reduce this cost of the carbon fiber of means automobile and other companies are going to use carbon fiber composite in the automobiles. This is one of the application, this technology developed in NPL and transferred to the industry also. That is carbon fiber composite illusory fixator ring. So earlier, this fixator ring, if you have any deformation in the legs or your hand, we require to increase the leg height. So we have to cut the bones first initially, and then we have provide the support by steel ring and steel rod. Okay, so I'm showing here in one of the photograph, it is used all steel rod and steel rings. And in another, this is carbon fiber composite rings and carbon fiber steel rods. But by using this carbon fiber composite ring, there is a sudden almost 2-3 times weight reduction in the system, and it is very good for easily, patient can easily walk, he can easily survive. So that's why it is very much important, this carbon fiber composite rings in the area of medical, in orthopedic, particularly orthopedic applications. So I told earlier about the carbon fiber polymer composites. Then there is carbon fiber, carbon composites. So what is the carbon fiber, carbon composite? So carbon fiber is a reinforcement. But when we are reinforcing this carbon fiber with any polymer, they doesn't have whole carbon content. They have sometimes 40 to 50 content. If we have to make the carbon composite, we have to heat treat this material to 1000 degrees centigrade or more, and we have to remove the other elements. We have to keep only carbon. So in this process, we will get the carbon is a reinforcement and binder is also the carbon. That's why it is called carbon composites. So these carbon composites are used at very high temperature material where it is required, particularly in the area Agni missile. So NPL developed this technology of the carbon composite in 90s. That time Abdul Kalam was the director of NMRL. NMRL. He came to NPL and asked the NPL to develop the carbon-carbon composite, and NPL has developed that carbon-carbon composite, and then later on this technology transferred to DRDO. Now DRDO is making all the carbon-carbon composites based on the NPL technology. So this just I am showing how to make the composites. You have the carbon fiber, unidirectional carbon fiber. You have to convert into the fabrics, is it two-dimensional? Yeah, weave into the three-dimensional. We can get three-dimensional composites. So this is the preform. This is only carbon fiber preform, three-dimensional. Then we have to infiltrate. We have to impregnate. Okay. So this may be polymer matrix. Yeah, it may be thermosetting or thermoplastic. Then we have to, after impregnation, we have to convert into the carbon-carbon. We have to give the heat treatment at 1000 degrees centigrade. Yeah, sometimes the heat treatment under the autoclave at 600 degrees centigrade. And then further we have to heat to different temperature. Then we will get the carbon fiber reinforced carbon composites. So both the component is carbon-carbon. So that's why it's called carbon fiber, carbon composite. So this is the peculiar structure of the carbon-carbon composites after whole treatment. So it gives the density around 1.8 to 1.9. To get the density of 1.9 to 1.8, we have to infiltrate. We have to control the density of the composites by infiltrating more and more carbon. So then we can achieve the density of 1.8 and 1.9. And finally, we have to get different types of product made from the carbon-carbon composite. We have to do machining, whatever we required. So this is the first carbon-carbon composite node tip developed in the NPL, and this is implemented in the Agni missile, first time in the country. Later on, subsequently, this material used carbon-carbon composite in number of applications. Another area, this carbon-carbon composite, NPL is developed this technology for nuclear reactor. Because this nuclear reactor operating at very high temperature. So we required a stable material while operating this nuclear reactor. So for that, NPL has developed this carbon-carbon composite tube technology in NPL, and transfer this four half-meter length carbon-carbon composite tube having 12 holes in their diameter also. And if you see, there are 12 holes, and in the center there is another hole. So these holes are used for putting the fuel as well as coolant in the nuclear reactor. And this technology has been transferred to BRC. Another area is activated carbon. So NPL has developed the activated carbon technology using viscous rayon fiber or fabric. Okay, so starting material is again rayon fiber, viscous rayon fiber, a fabric, and we have to convert this viscous rayon fiber into the carbon fibers, and then converting carbon fiber by activation, physical activation and chemical activation, and we can make the fabric, activated carbon fabric. And if you see the structure, there is a porosity showing in the figure, and that can be nowadays used in different your mass and filtration assemblies. And this technology NPL has transferred to the HEG Bhopal. Another one issue, technology is regarding to make the activated carbon from the juice stick. In northeastern state of the country, there is a lot of juice stick, that is the waste material. So people are again burning this waste material and creating the pollution. So National Juice Board in Kolkata approaches NPL, why should not you are converting this carbon, waste material juice stick into the activated carbon. So NPL has developed this technology. So when jute plant is there, they are taking the fibers. Okay, so fibers are using a number of applications, but sticks cannot be used. They are just burning for firing. Okay, so NPL has developed this technology to make jute-based carbon fiber, jute-based activated carbon, because again this jute stick having almost more than around 49 to 50% of the carbon. Then other element is oxygen, hydrogen, nitrogen. When you can heat treat, we can remove this oxygen, hydrogen and nitrogen, then we will get only carbon. And this carbon will be treated, activated by some physical or chemical treatment, so we can get the activated carbon. Technology in NPL, and these are so many applications of the activated carbon. And this is the, if you can observe, by naked eye you cannot see how the porosity is looking in the activated carbon. But if you can observe this activated carbon under scanning electron microscope, you will find out the complete porous structure. Okay, this complete porous structure that will give very high surface area, and that high surface area is very much important for to absorb the pollutant, chemicals, whatever it may be, air water filtration, any applications. Another thing is that you know in every year October, November, there is a headlines in the news. There is a fog, the pollution. So that pollution is coming from the burning the rice straw in the or adjacent state, particularly Punjab, Haryana, and some part of the Uttar Pradesh. Okay. So this is one of the issue with the farmers, because when this crops is growing and the crops, and they want to show another crops, and there is only time period only 15 to 20 days. So it is very difficult to collect the stubbles from the field. So what the farmers are doing, they are burning in the field. Burning in the field, they are generating pollution, and mainly the carbon dioxide maximum. Okay. So to solve this issue, we have developed one technology how this waste biomass, crop stubble, can be utilized into energy generation application. So how we can use again for energy generation application? If you can use this rice straw directly in the thermal power plant, there are some issues, because there are some inherent problems of the biomass, because very low density, hydroscopic, okay, and density, calorific value. So it is very difficult to use in thermal power plant. To solve this issue, NPL has developed the technology that is called torrefication, to convert waste biomass into the biocoals. So that having the properties equivalent to the coal, particularly the calorific value, it should not be hygroscopic. It converted into hygroscopic to hydrophilic to hydrophobic. Then fixed carbon content will be increased, moisture content will be reduced, and then it can be used in the thermal power plant. So government and NTPC is already, they are using 10 to 15% of the this biocoal, we can say biocoal, in the thermal power plant. But in future, there is a proposal from the government, we have to increase slowly and go to 100%. How we can, our thermal plant, power plant can be utilized 100% biocoal, so we can replace the coal and we can reduce the carbon dioxide emission in the environment. When we are going to use this biocoal, okay, so whatever the carbon dioxide we are generating using this biocoal, that can be absorbed by the plant again during the photosynthesis process. So there is net zero carbon, okay. So that's why this technology is very important, and this technology is developed in NPL. Another component of this rice is rice husk. One is rice straw, and this is the rice husk. So rice husk is also in rice mill. If you see a lot of waste, there are some cases, some percentage of rice husk are utilized for some particular applications, but it is again a waste material. So how this waste material can be utilized into the value-added product? So again, NPL has developed this technology to make the rice husk particle board from the rice husk. So we have the risers, we have to grind, because one of the advantage of these risers that have being lot of silica. So silica can give the strength to our board as compared to what the board in the market made from the other type of wood products. So NPL has developed this technology, which consists of risers powder plus some binder, small quantity of binder and some additive, and by compression molding we made the boards, raw boards, and that can be again stacking different type of we can say plywood. We can make different type of furnishing raw material. So another area the NPL is working is hydrogen. So government has announced hydrogen mission. So in this hydrogen mission there are three parts. One is hydrogen generation, storage and utilization. So hydrogen-based polymer electrolyte fuel cell is a clean source of energy source which can convert chemical energy into the electrical energy, and chemical energy is only just hydrogen and another is oxygen. This hydrogen is split into the hydrogen positive ion and electrons. Hydrogen positive ion reacts with the oxygen and that can generate the water. So there is no any pollutant, no CO2 and nothing. So this technology NPL has developed. So this technology includes, there are different labs of the CSIR that is under NIMTILI project. So NPL having some particular responsibility to develop the two components of this hydrogen-based fuel cell. So particularly when hydrogen-based fuel cell we are talking, the major components are gas diffusion layer, polymer electrolyte membrane, catalyst and bipolar plate. So bipolar plate is playing important role because it contribute more than 70 to 80% of the stack volume by the bipolar plate, and it will cost around 40 to 50% of the cost of the fuel cell stack. That's why this material is very important. So this NPL has developed the indigenous technology as gas diffusion layer, that is a porous conducting carbon paper, as well as graphite composite bipolar plate. And we are working with different industries. We have worked with the Reliance industry, Thermax industry. Also we are working again different industry to fabricate this indigenous material for the developing the indigenous fuel cell in the country. So another area our group is also working on the carbon nanotube. I don't want to show more detail, but you know why carbon nanotubes are important due to high mechanical property, electrical property and thermal property. So we have developed the process technology of making the multi-wall carbon nanotube in NPL, and we are making this multi-wall carbon nanotube in a batch scale, 100 gram per batch. If you can see in naked eye, you cannot see it is a carbon nanotube or what. It is just look like a powder. But if you can observe in the scanning electron microscope, HRTM, then you can find out there are the nanotubes. Okay, so that diameter is varies from 50 nanometer to 100 nanometer, depend upon processing parameters, how we are making. And one thing, how we can characterize this carbon nanotube is one important is Raman spectroscopy. First step, our material is carbon nanotube or not, because when we are seeing it by the naked eye, it is just like a powder. But first we have to do the Raman spectroscopy. So we can know it is a carbon nanotube or soot particle or any other material. So NPL have this technology of making the carbon nanotube 100 gram per batch, and it is a very important material for different applications. So one of the application of the carbon nanotube is to use as a catalyst. So I have told you the hydrogen based fuel cell, catalyst is playing very important role for dissociation of your hydrogen plus ion and electrons. So we have to use the platinum catalyst. But if you can use the platinum catalyst, one day we don't have the platinum. So how we can reduce the quantity of the platinum catalyst in the fuel cell application? So we have to use a high surface area material. So carbon fiber having very high surface area. And we can deposit this platinum catalyst on the carbon nanotubes. Then we can able to reduce the catalyst in the hydrogen fuel cell by 50%. So this is one of the example of application of carbon nanotube as a catalyst support for polymer electrode membrane fuel cell. So these are the different application of the carbon nanotube. Our group is working on this, almost all application as a anode material for lithium-ion battery, supercapacitor, photodetector, ballistic protection, EMI shielding, thermoelectric materials, and so on. So I have shown carbon nanotube is just like a powder. So it can be not utilized directly somewhere. Okay. Even though we can make the composites using carbon nanotube and polymer, we cannot able to get good properties. So how we can utilize the carbon nanotube in more greater extent? So one thing is that we can make the carbon nanotube paper. Okay. So just like a paper, it is a bucky paper, carbon nanotube bucky paper. NPL has developed this technology. It does not have any type of binder. This is just carbon nanotube. So this is made by the paper making technology without any binder. We have to disperse initially carbon nanotube in some solvents, some surfactants, and use the paper making technique, and we will get the carbon nanotube paper, and it is flexible also. So one of the application of this carbon nanotube bucky paper is anode material for lithium-ion battery. So earlier, means whatever commercially lithium-ion batteries we have, they are using graphite as a anode material. So graphite in the powder, form of powder. Okay. So they have to take again conducting collector, that is copper, and then they have to coat copper graphite on the copper plate, copper sheet. So it acts as a anode material for lithium-ion battery. But if you can use this carbon nanotube paper directly, because it is conducting, self-supporting, so it can be used directly as a anode material for lithium-ion battery. So this is the one example. The carbon nanotube bucky paper is used for making the anode material for lithium-ion battery with the help of our sister laboratory, Sikri Karaikudi, and they have the full facility to make the lithium-ion batteries. Another application of this carbon nano bucky paper is in the ballistic application. So if you know, the for ballistic protection is very much important for our soldier and police force to protect from any type of threat. So this is the waist plate, it having the weight more than 2 kg. And it made from ultra high molecular weight polyethylene fabrics, as well as there is one other plate made from the ceramics, that is boron carbide, sometime aluminum oxide. So how can you reduce the weight of this waist plate? If you can reduce the weight of the waist plate minimum 100 gram from 2000 gram to 1900 gram, it is also makes the impact, most impact while using this type of material by the soldier. So NPL has developed some technology by utilizing carbon nanotube paper and reducing the some weight of this ballistic plate. Another area, you know, this carbon nanotube are very tiny particles. It's very difficult to use in all the application. So how we can utilize, how we can make the fibers? Again, if you know the cotton fibers, fibers, again there is a lot of small fiber, then we are spin into the fiber, into the thread. Then it can be utilized for any application. In such a way, NPL is also trying to make the carbon nanofiber threads or carbon nanofiber fabric directly. So NPL has developed this technology for making multi-wall carbon nanotube sheet by a floating catalyst chemical vapor deposition technique, and that sheet is collected on the mandrel, and this is around almost 1 meter long. sheet. And in this case, most of the carbon nanotube align in one direction. So this technology has developed in NPL, and you can then spin this carbon nanotube paper further. We can get thread-like material, and that having the conductivity as good as our copper wire. So this just I am showing, this is the carbon nanotube thread, is used as a cable for instead of copper wire in the bulb. If you see, it is glowing and it is as good as a conducting. It is almost from 2-3 years in our laboratory. This cable is working as a conducting cables, carbon nanotube. So there are different applications. If you know, in the one Airbus, one plane, they are using more than thousands of kg of the copper wires. And you know the density of copper and you know the density of carbon nanotube. We can significantly reduce the weight of the aircraft. If they are using 1000 kg of the copper wire, it can be reduced to 150 kg if you can use the carbon nanotube based cables instead of copper. So these are different applications in the of the carbon nanotube ions. Then our group is also working on the graphene. So graphene is again a 2D materials, and I just told you it got a Nobel Prize in 2010 in a very short time, and it's very important material. So graphene is known from long time. When we have the graphite is nothing but a stack of the graphene layer. There may be more than 1,000 lakhs of graphene layers stacking on the graphite, in the one graphite. How the discovery again came? They have just taken the graphite, put the scotch tape and peel the single layer. And then they observed in the scanning electron microscope what is that material. They found the hexagonal structure of the graphene. It is a single layer, and they got the Nobel Prize for this graphene discovery. And single layer graphene having the transparency more than 98%. They have very high carrier mobility, very large surface area, and superior mechanical property. And NPL, we are synthesizing this graphene by chemical vapor deposition technique on the copper substrate, and then we are separating the single layer graphene. So far we are making 1 centimeter by 1 centimeter area, and there are different applications of graphene. In case of touch screen, in case of supercapacitor, in case of high carrier mobility, very strong composite materials, batteries, and nowadays it is used in the monitoring sensors. Most of the sensors nowadays made from the graphene material, and that particularly they are just like a pressure center to monitoring the health. So another area our group is also working and develop the technology to make the nanofibers, continuous nanofibers from polymer and convert into the carbon nanofibers. So by electrospinning technique. So if you see here, it is just polymer is spin by applying the high DC voltage, this electrospinning, and we are getting the nanofibers of the range 200 to 400 nanometer diameter. And they are continuously coming from the syringe pump, okay? And they are having very large surface area, lightweight, and membrane-like structure. And we can incorporate any type of materials, nanomaterials also in these nanofibers. So they have different applications. So these are the different applications of the, again, nanofibers. So one of the application, by using, we are making the nanofibers from biopolymers, that is again the lignin. So nowadays everybody is working on sustainability. So lignin is a biopolymer, it is industrial waste. So NPL has developed this technology to make the nanofiber sheet from the lignin by electrospinning technique, and it is used as a anode and cathode in the supercapacitor application. And we made all solid state supercapacitor by using carbon nanofiber sheet that is derived from the lignin. So there are different applications. So So these are the few examples of the different technologies. Means our group is working in the area of carbon materials. Also, we are providing some testing facility to the industry also. We have the facility of thermogrammetry analysis, differential calorimetric analysis, thermomechanical analyzer for measuring the strength. That may be bending strength, tensile strength, compressive strength. We have the universal instrument testing machine. Then we have the dynamic and mechanical analyzer to measure the mechanical property of the nanocomposite. We have the BET surface area instrument for measuring the surface area of the activated carbon, carbon nanotube or graphene, any type of powder materials, carbon-based materials. So these are the few examples of the different type of carbon materials developing by our group in NPL and transfer different technology to different industry also, and we are working on the advanced technologies also. So any industry is interested, they can contact with our group for any type of, they want to solve any type of problem related to carbon materials, any type of carbon materials. It may be nano, it may be micro, any type, carbon fiber, graphite, whatever it may be. We have a lot of expertise in our group, and we are giving our consultancy services, technical services. We are taking the industry project. We are taking institution projects. So these are the different things our group is working. Apart from, our group is working on the thermoelectric materials, then photonics material, photovoltaics material. I think my colleague Dr. Pankaj will talk about something photovoltaic materials on the flexible solar cell. Thank you very much. क्या हुआ? क्लोज कर देना, निकाल देना, बंद कर दे.
Okay. Now the floor is open for discussion. Any queries, question, discussion?
मुझे तो एनपीएल के लोग दिख रहे हैं यहाँ सब. Huh? There is no question, no? So I think, Indian industry is not known for most of these materials, because they know the carbon, but they maybe know about the coal is much better. But what are the different application in different area, high-tech area? I think if you one day you can see all the technologies, even your anywhere, you can see the day all the materials made from the carbon material, that may be carbon fiber composites, graphene composite, carbon nanotube composite, anywhere. Because government is also trying to ban all this plastic. We don't have the wood. How long sustained we can on the wood? So we can, one day we are going to replace wood by the carbon fiber composite. One day we are going to replace steel by carbon fiber composite. We are already, this laptop body, that already made in carbon fiber composite. But this is one of the problem is the cost. Cost is very high. That's why people are not going to use this type of materials. But hopefully, in future, you can see more carbon products made from the carbon fiber, carbon nanotube, graphene. Thank you.
Okay, sir, thank you. For token of appreciation, we would like to give one moment, sir.
घर के लोगों में थोड़ी दिया जाता है.
Thank you, sir. Next one presentation from our industry partner, not partner, from industrial person, Environment Tech. He is going to give his presentation about his industries and his views and what are the collaboration with NPL and what are the things he can do. He will present this. How much time? Time? 10 minutes. Okay.
So good afternoon everyone. This will not be a technical presentation. I will simply brief you about the Envirotech instruments, what are our products, how we have developed, and how we are associated with laboratories like NPL, NIRI, etc., etc. So our works is stationed in Delhi, Okla Industrial Area Phase 1. And we started something around 40 years back when Air Act was enacted in the country. One of the objectives of the Air Act was that our government has to provide clean air to the citizens. And this providing clean air, it was very much difficult to meet this objective if there is no monitoring equipments and competent and trained manpower available in the country. So Envirotech was, its birth took at that time, and prime objective was to make the instruments available, indigenous instruments available in the country for monitoring of air quality and emissions. And we took the challenge of providing because at that time there was no manpower available for operation of these instruments. And most of these instruments at that time were imported from USA, UK and other European countries. The first of the instrument which we have developed was the stack emission monitoring sampler. At that time the instrument imported from USA, that was a very complex instrument. And in fact it was not usable in the Indian conditions. What sort of conditions? Because that instrument need to be hanged over the stack. Only then it can be used for monitoring of the stack emissions. And there were no provisions available on the stacks in India. Even portholes were not available. But only porthole was not sufficient. One need to place a monorail at the stack where the instrument can be hanged. So keeping all those complexities in mind, Envirotech designed an instrument which was simpler. It was cut in pieces. So one can measure temperature at one time, velocity at another time, pressure, third time, and then one can take the sample or draw the sample at another time. So it make the process of sampling simpler, and it was and after making a simple porthole in the chimney, one can do the stack emission monitoring. So this was the first instrument, and another change which we proposed in our instrument was, in the imported instruments one has to do only particulate sampling at a time, and doing the gaseous sampling they have to do it next time. What we did, we diverted this extract a sample from the stack in two streams. One was going to the filter paper, other was going to the gaseous sampling impingers or the absorbing solutions. So at the same time one can do the particulate sampling as well as the gaseous sampling. So this was the first instrument. We developed something around in 1981, 82, 83, 84, 85. We were going on developing, changing the designs of instrument, and lots of improvements we did. Then around after 10 years or so, the Indian this national ambient air quality standards came into force, and then we were to monitor the PM10 in ambient air. For PM10, no instrument was available. Indigenous instrument was not available. We were again dependent on foreign countries. We developed the respirable dust sampler. It was developed with the help of NERI, CSIR-NERI. The one of the vital and critical component in a PM10 sampler is the particulate fractionation device. And that particulate fractionation device usually used in the US EPA approved or certified instrument was an impactor, but considering the portability of the instrument, CSIR-NERI has given a design of instead of an impactor, we went for the cyclone separation device, and that cyclone was designed by the CSIR-NERI. And nowadays we are getting it certified that cutoff size of the cyclone is up to the mark or not. It is getting it, we are getting it done through the CSIR-NPL. Then again there was a standard for PM 2.5 around 2000. Then PM 2.5 sampler was again developed, first instrument in India by Envirotech, and that design is as per US EPA, but again certification is by CSIR-NPL, which we have only 2-3 months back we have get it done from the CSIR-NPL. Since long this monitoring of meteorological parameters, in the old days these instruments used were of the recording type, where a chart paper was used and all that. So we were the first manufacturer who developed a data logger type instrument. Nowadays there are several instruments available, but in something around 2000 we developed the data logger type of meteorological instruments which monitors wind speed, wind direction, temperature, humidity, rainfall, etc., etc. We also monitor, we have instruments for monitoring of work zone air quality. For this we have instruments like handy sampler, personal sampler. We have a provision of monitoring work zone area, and the workers exposure can be monitored. So there is a provision available for fractionation of the this workplace dust into different sizes. So that cyclone separator is available for the personal samplers also. And with the time there was a requirement for real-time monitors. Real-time monitors, sensor-based instruments are coming popular nowadays, though these are not very much suitable for compliance purposes, but for research purposes. So we entered in this area also, and we ourselves have developed a sensor-based real-time monitor for PM10 and PM 2.5. We have also developed an instrument for PM1 monitoring, though it is not part of the National Ambient Air Quality Standards. So My point is that all sort of instruments which are required for monitoring of ambient air quality as well as stack emission monitoring, Envirotech is manufacturing, and we are associated with the reputed laboratories of who are having the R&D facilities for calibration and standardization of the all these instruments, and they are also helping us in improvement of the design of the instruments available with us. We are also collaborating with the foreign instruments, specifically for real-time monitors which are sensor-based, and the real-time monitors which are as per the technologies approved by CPCB and the Ministry of Environment and Forest. So all those instruments we are importing from different countries. The basic components we are importing and we are assembling, and we are making these real-time monitors for PM10 and PM2.5. The approved technology for PM10 and PM2.5 monitoring in ambient air is the BAM, beta attenuation monitor. These components we are importing from foreign countries, assembling, we are putting the data logger and other things, assembling it, and we are making this available, these instruments available in the country. So this is something about our products. And basically we are concentrating ourselves to the samplers, and lately we have undergone into the area where we are importing the sensor based or the BAM based instruments and assembling here. Some research projects we are doing with IIT Delhi, IIT Kanpur, IIT Chennai, IIT Jodhpur. In these research projects we are developing the sensor based instruments for PM 2.5, not sensor based instrument but specifically sensors, so that we can develop the instruments. So, and NPL, with NPL we have gone with the development of bacterial filtration assembly. For that the technology was transferred today itself. In future also we are thinking some of the areas which we have the core competency and the R&D facilities are available with the organizations like NPL. We would like to collaborate in those areas. So this is all about Envirotech and our planning. So thank you very much.
Thank you very much, sir.
Okay, thank you.
Are your any queries? Floor is open for discussion now. Anybody else?
Let me ask a question. How many of you know AQI? Air Quality Index. It is a indicator of the pollution, and we are the manufacturers for the measurement of this pollution. Okay, thank you.
Okay, sir. One question.
Yes, sir.
How much or how much quantity percentage you are importing? Your how much percentage wise? Right now you are getting from India and importing from foreign countries.
Let me tell you, in India, most of the state boards, Central Pollution Board, most industries, most consultants, and most academic institutes have our samplers, not the real-time monitors. We are slowly entering and capturing that market or that area, but samplers we are the master. maybe maybe around 40 to 60% market is with us in the country and the neighboring countries also. Yeah. Thank you. Thank you. Yeah, yes, we have with Shankar Agrawal ji, we are having at least one meeting in a month, every month. In this, we are discussing all these aspects. Yeah, thank you so much.
Token of appreciation, all Dr. Sir Takate to present small memento. Thank you all. Next we move on the presentation from Dr. Dheeraj Alsetti. He is air quality scientist from Environmental Defense Fund. He is basically from non-profit organization. We are welcoming, sir, please.
Hello everyone, I am Dheeraj Alsetti. So I am working as an air quality scientist with Environmental Defense Fund. In EDF, we are working in the field of air pollution since last 6 to 7 years, and we are mostly working with governments and technical partners such as CSIR-NPL, then TERI, and recently now we are trying to start collaborations with NPL as well. So we are trying to understand how we can build capacity among various government organizations and the urban local bodies, so that air quality can be managed and controlled at various levels at a local scale. So some of the basic verticals which we are focusing is air quality monitoring, then emission inventory and dispersion modeling at a very fine scale, so that we can identify local solutions for different cities and different hotspots. So in air quality monitoring, we are working mostly with low cost air quality sensors. We are working with sensors because we need to monitor air quality at a very fine scale. So to monitor and cover this spatial area at a very fine scale, we need more number of instruments. So we are mostly working with air quality sensors, and we are trying to do a science work by evaluating different types of sensors that are available in the market, and then we try to evaluate their performance, their precision and accuracy by collocating them with the reference grade monitoring stations such as CAQMS installed by CPCB, IMD or state pollution control boards. So we are trying to partner with urban local bodies and then install these sensors in a very fine scale, and then we are trying to identify micro sources by doing fine scale emission inventory as well. Then once we get the different types of sources and their emission profile, we'll try to understand what are the ground level concentrations of these pollutants, and we will prepare tailor-made solutions for these different sources, and we'll try to come out with a methodology how we are reducing these pollutions or emissions on ground level. So our main idea is that once this pilot study is successful from our end, this same pilot study can be replicated for the whole city by the urban local bodies. And one of the major interests that we are having is we are trying to improvise the efficiency of this monitoring with the help of air quality sensors. So not only quantitative measurements, but also we are trying to understand how qualitative measurements using air quality sensors can be helpful to identify the pollution hotspots and how we can mitigate the air pollution at a fine scale with help of these sensors. So one of our interested project is how we can improve the performance of the sensors and how these sensors standards can be brought in so that air quality monitoring can be done at a very low cost and a very reliable data. So for this we are trying to collaborate with NPL as well, and this is in a very initial stage, and we are hoping that this collaboration will bring out some kind of technical specifications or standards for air quality sensors, and sensors can be more effectively used for air quality monitoring, and it can be deployed at a very large scale across a city, such as air quality sensor network, and then it will be easy for us to manage the air quality, and all this data that comes in the dashboard, with the help of that the urban local body or government authorities will be able to take decisions to quickly act on the pollution levels or hotspots. So this is a brief background on what we are working, and yeah, so that's all. So if any questions are there, I'm happy to take it.
Any questions? Now floor is open. Ask one question.
Yeah, sure.
Okay, how many people associated with your activity?
So we are working right now in more than 7 cities, and we have 4 technical partners signed with us. Then also we are in contact with all the urban local bodies of these 8 cities, and in our team we have around 8 to 9 people who are taking care of this day-to-day works, installation of sensors, data analysis, and all those stuff.
Okay, I think you are spread over India.
Yeah. Yes.
How we are getting support from apart from central government and state government, because basically your setup is little bit different from
Yes.
NPL or some government organization.
Yeah.
How we are getting support from local and state and
Yeah. So basically we try to speak to urban local bodies in any city, and because of the national clean air program that is in existence, so it is easy for us to approach urban local bodies and speak with them, and when we are coming out with a solution, a package solution for local air quality kind of management, they are happy to associate with us, and we were able to successfully work with many of the state governments as well.
what about our NPL?
Yeah. So with NPL, we are trying to establish collaborations with Dr. Shankar Agarwal. Recently, we are meeting him, and we are trying to understand how this air quality monitoring can be more streamlined, and the sensors can be, this performance can be analyzed, and how we can standardize these kind of things. Yeah. Thank you. Thank you very much.
So now we are concluding the other down. We can any doubt? Actually, I forgot. Yes, sir. So I would like to call Banu Pratap Singh to present a memento as a token of appreciation.
I think we have a very good presentations today. Yeah, so I have a very good presentation today, especially starting from the air earth, the air purifier, and then we have our own presentation by Dr. Bhakate. Then we have a presentation, and then recently that so all together I think very good, combination. So we learn many things, but still we have a many presentation for tomorrow and day after tomorrow. So we will continue with this, and because today we don't have much time now, so I request all of you to visit the stalls, because some stall will go, and tomorrow we will have a new stalls. So you can go around and see the stalls. Tomorrow we will have some new stalls, so you can also take a look. And then tomorrow again we have a presentation from our industries as well as our own presentations. So with this, I think presentation session we can end up here, but still we can look around and see the stalls and technologies what we have. So I request you to please visit the stalls. Thank you very much. Yeah. Yeah. Yes, tomorrow session will start from 10 o'clock in the morning. Yes, of course. Yeah. There is a no connection between Metrology Conclave and here. So here we can continue, but after sometimes you can also visit there. So it's no issue. You can enjoy this, you come here and then go there. In this way you can work.